Hello, hello, hello. Welcome back to another LaserBeam Live. This is number 14. Thank you for joining me, whether it's morning, afternoon, evening, or night for you. I appreciate you joining me, spending a little bit of time to play with the laser. Today, this is part 3. We tried laser engraving on metal using Brilliant's black metal laser spray or laser ink. And first time, we had permanent results, but we had to play with the settings a little bit. That was on the brass, but it didn't come out as well as I liked, but it still stuck onto the actual metal. Second part, we tried the steel. It might be a steel alloy kind of thing, and nothing stuck. We were able to wipe away the ink after. This time we're going to be trying the steel again, but we're going to be running it a few times. So we're just going to be running passes. So I chose a very simple design today, just some text that says hi, and we're just going to run it like 5-6 times. We're going to see if it's possible to engrave on this piece of metal that we have. I believe it's a steel alloy, but I want to be able to just test it, go at it with everything 5-6 times, and see if it sticks. And if it doesn't, then we're going to do a quick project on the brass, and I know that one will stay if we get the settings right. So that's what we have planned for today. So thank you for joining us. Let's look at the chat. Jack in the shop was first. Usually he's a little bit late, but today he was first. He was number 1. Yoel, I forgot how to pronounce your name. Lowell. I know it's not the L. I know I'm not supposed to pronounce the L. Please tell me again. Remind me how to pronounce your name. Appreciate you. Ethereal Blitz, Bill, Dana, Nicholas, Technically Christmas. Thank you for joining. Thank you for joining. Thanks for being in the chat. Thanks for typing in the chat. We appreciate you. Lol. Sorry. Lol. Mick Steele, Scott Hughes. Scott, thanks for joining. Thanks for coming in. Thanks for saying hello. Thanks for joining us. I just want to bring this thing to a conclusion, this laser spray. If we don't figure it out today, it's not getting my stamp of approval. It doesn't mean that you shouldn't try it out, or if you like, no pressure, but it doesn't mean that you shouldn't try it out. But if I can't figure it out with steel alloy today, it's not really getting my stamp of approval. Obviously, it could be the metal that we chose because it is sticking on the brass, but it's not sticking on the steel alloy that I have. So, but if I was going to spend money on this, I would want it to kind of be universal. I don't really want to worry about what type of metal it is, but that's just me. You guys can have your own opinion. So that's what we're going to do. And in the next stream, hopefully we'll be bringing it back to laser. We'll be talking about software, rotary software and all that stuff. I've learned a lot over the past couple of weeks about the rotary software and how it works on the back end. So we're going to be trying to play with some more rotary projects. So yeah, thanks for joining. Let's get started. Should we just jump right into it, or should we chat it up a little bit? Let's just jump right into it. One sec. I just want to bring this over. Sorry, just having a little bit of technical difficulties with my multi-screen setup here. There we go. Should be all good now. Got light burn here. So super simple, just high. I think we're gonna run it at about 15 millimeters per second, 100% power, and then we're just gonna run it over and over and over again. So this might be a little bit boring, but I just really want to get to the fact that, is it the metal that we have, is it the spray, or is it the settings? That's what we're trying to figure out today. So metal part 3.1 .nc. Got to save as a .nc just to avoid any weird things from happening. And we're just going to save it here. So we can pop that back up. Good evening, good evening, good evening. Warren's in the chat. Derek's in the chat. Technically Christmas, do we currently have any thoughts on using a camera to scan the piece, then apply the image to be burned? We can definitely do that. That's something we could definitely do. We got cameras. We could set something like that up. Thanks for the suggestion. That's actually super interesting. I haven't played with the camera functionality, but it is one of the coolest ways to use light burn. So I will definitely check that out. And we could definitely do a stream where we look at the camera stuff. That would be cool. Jack asked, does GSender have an option to click on the design for the start from here? Currently, no. Just you set where you want your origin point to be when you're generating G code, whether that's with Vectric or or Lightburn. You're gonna set the origin point for that, and then wherever you set the origin at is where this is gonna be able to start, and where you're gonna be able to set your start point. Sorry, let me just. Pull up our code real quick. Where did this get downloaded? Metal part 3. Sorry, that took me a little too long to find. So we're just doing a simple hi. You can see GSender updated. That would be a cool feature. You could definitely send in a ticket and kind of probe. We can kind of get that probed in our software engineers. Hopefully they can think about it, see how easy it would be to implement something like that, see if they could add that to a future roadmap of features that they're going to be able to offer. So yeah, that's definitely something that they can look into. I will bring it up if I have the time, and definitely feel free to send in a ticket asking about future GSender features that you would like. It definitely helps the team kind of add to their timelines and add to their feature sets that they're looking to do in the future. So yeah, unfortunately I cannot guarantee anything. I'm not a software engineer, but it does sound like a cool idea, to be able to click, have a reference point, and then start from there. Like, yeah, you can manually do it, but it's a bit tougher. Like if it stopped at a certain point and then you pulled all the coordinates, you could go back there and kind of, yeah, it would be weird because then, yeah, it's just something that I would have to talk to the software engineering team about. I'm not the best at knowing the ins and outs of the back end of the software. I'm just the laser guy, guys. I'm just the laser guy. But very cool idea. Alan, yes, we are using a Mac with Lightburn. Derek, you can definitely send in a ticket and we'll chat. I can send you a little spacer to stop that from happening. Yeah, guys, if you're having little issues like that with the wires or anything like that, I could definitely just 3D print some spacers for you guys and we can get that figured out for sure. So Derek, send me a ticket if you already haven't. If you did send me a ticket, don't worry, I will get to you as soon as possible. All right, awesome. Kind of got sucked into the chat. You guys are awesome. What are we doing here? We just want to run this over and over and over and over again. I'm thinking like 5-6 times. If the ink doesn't stay, then I think it's more of just the alloy's not really liking the way the ink is, and then I'm going to switch over to the brass, and I just wanted to try to get a clean outcome with the brass because I know that will stick rather than this like alloy that I have here. Technically, Christmas asks, are the lasers in stock? If not, when will they be? They are in stock. There's a couple week lead time. I think right now we're about 2-week lead time, usually maximum 3 weeks. We usually ship within a week, but I think right now we're at about a 2-week lead time. So yes, they are in stock. They ship separately from the long mill, so don't worry about that. All right, awesome. Let's just jump right into it. So super simple design. 15 millimeters per second, dip switch 5, 100% power. We're just gonna run it over again. We're gonna run it a few times. We're gonna wipe it away, see if it sticks. If it doesn't stick, we're gonna do something with the brass real quick, and we're gonna call it a stream. All right, let's get started. Okay, that was a little too quick. I did not put it as a fill, so I'm just gonna resave that as a fill instead of a line. I do like the wizard wand. I think that's pretty cool. Trying to save, but I'm getting this like MacBook error sound. I don't know why. Okay, that's a little bit weird. I don't know what's happening to my light burn. Yes. Okay, we're good. So we're gonna do metal test part 3.2. Yeah, it was a hidden pop-up. I just couldn't find it on my screen. Do not call me for any tech support, guys. So I'm keeping everything the same so I can just go over the project, the line itself. I'll switch over to this so you guys can see it a little better. So the first one was just an outline, so I changed it to a fill, and we're just gonna run this a few times. Hopefully it doesn't take too long. Hopefully something like 5 minutes, we can run it a few times. No, I am not your tech support. I am, especially with Mac. With Mac, I have no clue what I'm doing. I'm like 3 weeks into my first MacBook ever. So, you know, I'm always a Windows guy, and yeah, and now I have a Mac. So everything feels foreign to me. Yeah, in this setup, Nicholas, red is not burn, and the blue or the black is burn. You know, everybody always tells me that the MacBook is great and it's way better than Windows and it just feels good and it feels intuitive. I'm yet to get to that point where I feel the same way, but I'm gonna keep pushing until I reach that point. Hopefully, it comes soon because like I feel like a grandpa with the Mac. I have no clue what I'm doing. Everything's complicated. Yeah, like I'm getting Bill is giving me condolences for having a Mac, and Dana, I do like a classic Big Mac sometimes, every once in a while. Yeah, honestly, I love Windows. Not love. Come on, love is very strong, but I really like Windows because I know exactly what I'm doing and I know exactly how to make things work, and I can be somewhat of tech support with a Windows computer. I just don't like feeling like I don't know what I'm doing, and that's exactly how I feel with the MacBook. Uh, but I'm not complaining. I feel like for the size, the aesthetics, I don't think you're getting a better laptop, especially with like the M1 and M2 chips. I think they're actually doing some really cool computing stuff and manufacturing and product design and all that fun stuff with the processing. Yeah, we're gonna figure this out. If this doesn't stay after 5, yeah, I can add to the laser list of material guides once I get this started. The only thing is I wanted that to be kind of laser only, whereas like this includes this, which we don't offer. So I feel like I don't want to trick anybody who's looking to get the laser into thinking that they can do metal just with the laser beam because you cannot. Yeah, Scott, like it's tough. Like you don't want to feel that confused. It just sucks, especially when you like how to use everything, you know how to deal with your own issues, you know how to problem solve with your own computer, and then all of a sudden you're having to like Google how to do X, Y, and Z. It's like the most basic stuff. Like I was having trouble just dragging a window from one side to the other, which is like that should not be a complicated issue. Yeah, Jack is the laser demon. You got the fiber, you got the CO2. Scott thinks all design software is better in Mac. I don't know. I'm gonna find out. It seems to be the same in terms of this. Like once I had all the softwares that I used on my Windows computer on my Mac, things like felt more normal. Oh yeah, this time I'm gonna remember, guys. If you are watching this stream, please like the stream. just give it a big old thumbs up. I appreciate you. The company appreciates you. We appreciate your support. You can help us a little bit by just liking the stream. Show your support a little bit if you want to. And if you don't want to, still do it because, because I asked. Don't ask questions. All right, we're almost done. This only took about 5 minutes, so we should have no problem just running it over and over again. Yeah, the thing is this laser spray, it doesn't have diode lasers listed. It has fiber lasers and CO2 lasers listed, but it doesn't have diode lasers listed. So if it doesn't work for diode lasers, the company's not advertising it for diode lasers. It's just some people might be able to get it work with maybe a little bit more power, maybe what we're doing right here with like running it over and over again. So I don't blame the company. They don't try to advertise to diode laser users. But us hobbyists, we got to try it and see it for ourselves. So that's why I bought it. That's why I'm trying it. And, hopefully like different metals are going to cool at a different rate, which means different metals are going to need different settings in order to get this spray to actually like set on the material, right? Like the brass was a lot easier just because of the characteristics of the metal, and the heat that was going into it. So I'm just hoping that we can get something working here, but I don't know for sure. What is the active chemical in the dye? Let's take a look. I don't know if they list their chemicals. Yeah, I doubt they do, because then people would just make the exact combination. Yeah, no list of chemicals here. They might have it on their website, so definitely you could check that out. BrillianceLaserInks.com. Yeah, they do have a full MSDS. You should be reading that before you use it, just like I read it before I use the spray. So always read your MSDS before using any type of spray or material or anything like that. Make sure you're not creating any toxic fumes. But yes, you can find that on their website and check that out. That MSDS, that brings me back to high school or university. Chemistry was always my worst subject. Yes, Scott, you should be able to do that. So that's almost like the reverse of what we're doing here, where we're putting something down and then we're like lasering the ink into the metal or on top of the metal. We're not actually engraving the metal. You can do the opposite, where you paint something and then you laser, or the tumbler is already painted, but then you laser the ink or the paint or the surface layer off of it, giving you like the illusion that you engraved the metal, but really you're just like revealing the metal and having that contrast to like the actual paint or whatever the thing is coated with. So yes, you can play with materials. Certain paints, certain powder coats might be harder than others. So definitely, I would say experiment with that and see if we have enough power to engrave that off your tumbler or your item. But yes, that is a way to go, where you paint something metal, and essentially you engrave away your text, and then it shows the metal in contrast to like your paint. All right, this is round number 2. It's round number 2. Let's go to 5. If it's not sticking by 5, then I don't know what to tell you guys. I tried my best. I'm going to move on to the next project because, as much as this was a cool idea, I have other things I want to do. I want to go back to rotary testing. I've been dealing with the software a lot and trying to align things in terms of like millimeters per rotation and finding out what Lightburn is actually doing with the code to see what we would like to be doing with G-Sender. Do we want you to just, import a regular project? and have G-Sender do the rotary conversion, or do we want to, well, and do we want to be able to, for you to do the conversion on Lightburn and then import the project and it be fine? We're just trying to figure out like how things want to work. And zooming out is like we're gonna have two rotary axes, one the chuck style, which is made primarily for the router. Sorry, a light just fell. Production here. What can I say? Sorry guys, let me just fix this light that fell so you guys can see the project better. There we go. Sorry about that. Yeah, exactly. Chris is in the chat, and that's kind of what we're dealing with right now. Or that's what I'm dealing with on the back end is, let's run it again. One more time. Encore. So yeah, whether like there's going to be like branches of like, do you want to be able to convert regular code, or like, let's just talk about the laser for now. But like, do you want to design in Lightburn? Don't use the rotary option in Lightburn. Take it into G-Sender and then just click a button and have it generate the proper conversions to be able to use our rotary axis for the laser. Then, if you have the chuck and you do that within Lightburn, same thing. And then if you convert in Lightburn and then bring it into G-Sender, then you want to be able to use the code as well. So it's all about figuring out all that fun stuff, Lightburn doesn't make changes to the G code itself other than like Y length. So it essentially comes down to the gear ratio of like the stepper motor moving our actual Y axis, 5 millimeters. You need to be able to convert that to the roller system rotating 5 millimeters in terms of its circumference. So that's essentially, it's just like the conversion there is what Lightburn is doing. And Lightburn is doing that by taking your millimeters per rotation and your diameter of the roller. So it knows, I'm moving this much across the roller. And then as long as that converts properly to your original, Y-axis kind of gear ratio, then, you telling your Y-axis to move 5 millimeters becomes the same as you telling your rotary axis to rotate 5 millimeters. And that's essentially what we're doing, or what I've been focusing on and trying to figure out, and I was able to figure out kind of, so that for our rotary roller system, you only have one variable to change if you're using Lightburn. And then in G-Sender, if you're using our rotary system, it should just be something stock to the point where we don't really have to change any EEPROM settings. But again, that's just like two branches of the flow chart in terms of how people are going to be using rotary in general with our G-Sender system. So lots to think about, lots to discuss. The software team has a big kind of project on their hands, a big speed bump to kind of get over, and I'm going to be trying to give them as much information as I can. Bill has been using Vectrix laser module more than Lightburn. Bill, what do you like more about the Vectrix laser module than Lightburn? I'd be interested, because I do agree with Mick that Lightburn is much more powerful. And that again, I forgot who suggested it, but I do like the camera system because that is a very cool feature of Lightburn that I do want to play with. Is just using a camera to kind of scan a design and then actually running that in Lightburn and on a laser. So Ethereal Blitz thinks Vectrix module is a bit limiting, but Bill likes the simplicity. So I totally understand that. We tried to get Vectrix. We tried to be able to sell the Vectrix laser module on our website, but currently it's not OEM, so they don't offer it for partners to sell. But they may be offering it in the future, so that's something we're going to look at. We're going to discuss, and hopefully, if it's easier for you guys and it's like the number 2 software that you guys are using, then we get to deal with that. It is limited, but some people like for me at least, simplicity kind of is great sometimes. I was obviously I chose Lightburn just because I like simple projects doesn't mean you guys are gonna like simple projects. So obviously Lightburn is just like the overall best software. So that's kind of where that became kind of obvious that like, okay, I'm gonna focus kind of on Lightburn. But in the future, if we're able to offer the Vectric laser module, I will definitely start using it to do tutorials and stuff like this and work in the stream. Scott, the laser module is always an add-on for all Vectric software. So whether you have Aspire or VCarve Pro, it is a add-on that you have to purchase. It's not too expensive, but again, you're kind of spending the big bucks on Vectric. So you would hope that the laser module isn't also very expensive. So this is number 3. So we're going to be running it 2 more times, and then we're going to check out the results. Hopefully it sticks. And it was just a power issue. We just didn't have enough heat, power, time under with the laser, and that's why it wasn't sticking. But if not, we're going to play with the brass, and we're going to call it a stream. All right. Let's do the greatest hits one more time. One more time, guys. Or no, sorry, 2 more times. I want to check this out. Does look good, but I don't really know what good is supposed to look like right at this point. Yeah, guys, does anybody in the chat actually currently use a third-party rotary axis? I know Jack might have one for his CO2 or his fiber laser. Because like I was talking about that flowchart of software and rotary, yes, Jack is actually right. It does have a simple interface, beginner mode. So Jack, so how do you like your rotary? Jack, do you use Lightburn to generate rotary code for your fiber laser? That's a question I have. Yep. And how do you like that workflow? I'm curious. Do you have any calibration issues in terms of setting up your chuck in Lightburn and then completing a project and making sure it's to spec? Because that's the next hurdle for me at least is figuring out a chuck style rotary with Lightburn and then figuring how to work that into the software of G-Sender as well. That's kind of the next step. First is obviously roller, Lightburn, G-Sender. Next is chuck, Lightburn, G-Sender, while the other engineers work on, Vectric, chuck, G-Sender, and things like that. And of course, we're gonna be able to go from Vectric to roller Vectric G-Sender for sure. Yeah, so that's great to hear. It shouldn't be too. It shouldn't be an issue at all to set up Lightburn for the chuck. If you do plan on, eventually getting the chuck rotary axis and then using that with the laser, shouldn't be too much of an issue. But again, we want that to be as seamless as possible within G-Sender. We don't want that to be a very jittery process, whether you're using Vectric, Lightburn, a chuck rotary or a roller rotary, whether you're using the router or the laser. We want that to be as seamless as possible. Oh, that's interesting. Thanks for sharing that. Sorry, Derek. What were you talking about in terms of then there is hope? Yes, Scott. That is the hope that the chuck will also work with the laser, just like it'll work with the router. So you kind of have two price points to enter the rotary market. If you know that you're only going to be using it. Oh, getting your rotary to work properly with Lightburn. Derek, what type of rotary do you have? Not that it matters, but Derek, what was your issue? Because I'm kind of working on getting like my prototype set up in Lightburn to work correctly and being able to repeat correctly. So maybe I can help you out with that. Maybe you can add that to the ticket if you feel like sending a ticket in. Send in a ticket about your laser wires, and then also you can include your issues setting up your rotary, and I can chat with you because I'm kind of in the same boat here where I'm trying to set things up and have repeatable results here. Oh yeah, you could 3D printing a chuck for your rotary. That's definitely good. Ours is going to be a little bit more high end than that, but definitely an option if you're looking for like a cheap chuck option. I'm pretty sure I've seen some on Thingiverse, some projects there that have roller and chuck 3D printable options. Obviously, you're going to need some hardware and some other stuff, but the majority of it being 3D printed, definitely an option. Um, if you're looking for something maybe a little less precise and you're willing to fiddle with the hardware a lot more, then definitely an option. Because I've seen the setup for our chuck style rotary, and it is very, 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 very nice, very high quality. Awesome, Derek. So I'll keep an eye out for your ticket, and then we can chat about that. Hopefully, I'll definitely try to help with the wiring thing, but hopefully I can add a little bit and about your rotary setup, and hopefully get you set up a little bit. I have enough trouble clamping to table. Be afraid of a roller-based chuck. So, in terms of the chuck rotary, there's going to be a whole mounting situation that we are attempting, because I don't want to promise anything, but we are attempting to build right into G-Sender to the point where you can drill. Is like the hope is to have kind of like an automated drill process so that you can set up the actual chuck, and then the laser rotary will just be more physically kind of set up, just like the laser when you're laying something down. As long as you got things squared a little bit, it doesn't really matter. You don't really need like work holding or anything like that. It's going to be the same thing for the roller, where it's just like we're going to physically give you a way to align things, and then you can go from there. We don't have the pre-orders ready for that. yeah, it's not going to be high quality when you're 3D printing stuff like that, Just like even like my prototype is majority 3D printed, and it's not going to be as high quality. There's still some slippage in the belt and tension issues like that. It's definitely not going to be as high quality as the finished model when we start making things out of more like rigid and precise materials. Yeah, sorry, Dana. Pre-orders are not open yet. You got to let us design in peace. We're hoping the summer. That's all I'm going to say. No promises here, but we are hoping the summer. Obviously, my product is a bit simpler, whereas their product is a little bit more intense. So, and we want to release them at the same time. At least that's my goal. And obviously, things can change, but that's my goal, is to release at the same time. So I want to give them as much space to create like the best product possible. I don't want them to feel rushed or anything. So yeah, I think it's all about how you design, right? You like, for me, like legs and mounts and things like that are very easy to be 3D printed because the thing that you're mounting is so rigid, right? Like steel plates, aluminum, like the extrusion and things like that. They're so rigid that through the 3D printers, yeah, it's really all about design in terms of like rigidity and obviously precision. But the higher quality and the more precise your parts, the more precise and high quality the machine itself will be. So definitely, definitely don't take that like as we're bashing 3D printed parts, because we 3D print a lot of parts. But it's all about using them in the right place to not degrade the quality of the product itself. So that's kind of what I'm going through. They have definitely gone through their 3D printed prototypes and are now looking at making like, proper steel, aluminum parts that might be a little bit more precise and a little bit better in the end kind of quality. So we are coming up to the end. I am going to go wet a shop towel so I can wipe away and check the results. So give me 1 second. Guys, I hope this comes out. But if not, I'm going to have some fun playing with the brass. Let's hope this works out. I'm hoping. I got my fingers crossed. I got my toes crossed. So we should be able to just wipe this away with some water, and then we'll see, or just a wet, damp shop towel, and then we'll see how permanent the results are this time. Yeah, like Scott, like the chuck, it is very similar to like a lathe. It's like you know, it's almost the exact same kind of process. It's just like a little bit smaller. All right, I'm gonna move this out of the way. And hopefully we got something. Nope. It wiped away. All right. As you can see, the same thing is happening here. Same thing is happening here where I can like pretty easily wipe this away. Like if I was using something, hard, like to scrape it, I would understand that. But like this is just like a damp shop towel, and with a little bit of pressure, I'm able to wipe this away. So again, it might just be the material, because I know this is not like just like regular, like mild steel or something. This is like I believe it's like an alloy or something, because it does come out better on the brass. So let me grab the brass. Let's run it a few times on the brass and see if we can get better results there. Because in our first time running these projects, we did have much better results with the brass. All right, so we got the good stuff here. As you can see, you can still kind of see the CNC there, and it was a lot harder to scrape off. Yeah, Jack, that would be great. If you could give me some pointers, if there's something that I'm not doing correctly, or maybe I'm just using, you know, something, maybe a straight aluminum or like a classic like steel would be a lot easier. Let's see what we get with the brass by running it a few times. And then we're gonna move on to the laser rotary roller. Hopefully I'll have my next prototype ready for you guys. Regardless, I'll still use the old one if it's not ready, and we'll come up with a new project. We'll come up with a new project to play with. Sorry, I got a bit of the paint on my workspace here. So maybe we can talk about light burn and what I was doing with the rotary axis. So essentially, if I were to enable the rotary axis, what is actually happening to the code that I'm sending? The only actual thing that's going to change based on my two inputs, roller diameter, which is going to be a constant, and millimeters per rotation, which for you guys is going to be a constant, but for me right now, I'm still trying to line up and kind of lock in, is going to be your Y height, right? Why is that? Like I previously spoke about, to move my Y-axis right now, all I have to do is tell GSender or any other code or this that I want to move it 5 millimeters, right? So if I make a line 5 millimeters, I put it in, it's going to move 5 millimeters. Easy, right? Why is that? Because the EEPROM settings are set up to work with this situation, this setup. The motors, the lead screws, everything is was set to work with that. So what happens with the rotary when we replace the Y-axis with a rotary axis is now 5 millimeters, left to right is not going to be the same as 5 millimeters rotated. So what millimeters per rotation and roller diameter tell it is how many millimeters does it take to rotate the entire roller 360 degrees. And from that, the code will essentially change your Y-axis to compensate. So your machine thinks it's moving so you're telling the machine to rotate 10 millimeters because your project is 10 millimeters in the Y-axis. And Lightburn is taking that 10 millimeters. It might change it to 3 millimeters because 3 millimeters to your controller, to your long mill controller, on a rotary axis is actually going to be 10 millimeters rotated, right? That might not make any sense. Me and Chris, we're going to have a chat about this. I'm going to try to relay this information to him as best as I can so that the software engineering team could have some good points to go off and make the software as easy to use as possible, right? But it comes to a question is, do we want these settings for you to also be able to input them within GSender. Because then I don't have to enable the rotary at all. I can just design this regularly, put it into GSender, and then put my inputs into GSender. Or tell GSender that I already put it into my inputs through Lightburn or a different software, and that it's already ready to go as rotary code. So, you know, that's kind of what we're figuring out now. I did have some success today where I was able to lock in a millimeters per rotation of 8.1, and then on 3 different size of diameters, I was able to get it to do like the full 360 turn and return back to its original point. So that's kind of how you know. So when we did our first rotary project, when we were playing with all this stuff and we got it to work by doing the lines here, when we were doing the lines here, yeah, exactly, Mick. So that's kind of how you know your settings are good. So when I did my first project with the rotary, I got it to work on one single diameter. So this piece is how I aligned it. And I think we came up with a number of about 7.6 was, did a perfect 360 when we set the Y length of the project to the circumference of this piece, right? But that was only one situation. That was only one piece that this was calibrated to. So I recalibrated it to 8.1, and what I found was that it didn't matter after that what diameter piece I used. Sorry, let me restart the project here. So what I found with this new number calibrated in, it didn't matter what diameter I was using. I was able to make it do a full 360 using the length of this, like using the circumference as the length on the y-axis. So that's kind of what I was looking for, right? Because it's essentially, you're finding almost the gear ratio of the roller axis and then how to convert that to make sense with the original gear ratio or reduction of the actual y-axis of the long mill. So again, I don't know everything there is to know about rotary software, but I'm slowly learning more and understanding the process of what's happening on the back end of this software more and more, so that we can kind of bring the best of Lightburn into GSender and also have it work with Lightburn very seamlessly. Hopefully that makes sense. Hopefully I didn't lose half of you guys. If you're still here, please like the stream. Give us a thumbs up. I appreciate your support. We appreciate your support. So yeah, run this about, 2 more times, 3 more times, and then we'll check out the results of this. So I'll run this, I'll probably run it about 2 more times, because I do want to end the stream in about 15 minutes. So guys, if you have any questions, if you just want to chat, let me know. If this ends up coming out fine, then I can give it like a 1 thumbs up, 1 thumbs down, because I had some success, but I didn't have perfect success with the other material. Jack, happy 27th anniversary. Jack, what are you doing on my stream? Go buy some flowers and stuff. What did you do for your anniversary, Jack? I appreciate you spending some time. Yes, Jack, you gotta, as important as my stream is, you do gotta attend to your marriage. I appreciate that. I appreciate you popping by and just period. Happy anniversary. Everybody wish Jack in the shop, our resident laser demon, a happy anniversary. Happy 27 years. That's awesome. That is something to be celebrated. That is definitely something to be celebrated. We appreciate you, Jack. Mr. Fiber CO2 Diode Laser Demon. Guys, I'm excited. I hope this one, 1 out of 2, I'll take a 50%. What are the odds, Scott? Maybe Jack in the shop is secretly your boss and you just never knew. What about that? Cue the conspiracy theory music. Yeah, you never know. No, I'd like to formally apologize for that horrible joke. It was beneath me. It was too easy. I am excited to see because from our first test, I know that the brass was easier to have a bit more staying on it. Okay, so maybe we have something. Maybe, maybe I will bring some stainless steel for next week. Just maybe I will come back with stainless steel. We're still going to do the rotary. That's going to be the main project. But maybe just when we start, I'll quickly run a project on stainless steel just to double check. Because I'd like to give you guys some ideas so that you guys don't have to use your money to test these things. If you have some brass, hopefully this comes out well. And you know that if you have a brass project and you'd like to do some lasering on it, then the laser ink spray is a possibility. And I'll bring a little piece of stainless steel for next week or our next stream where we will be doing a rotary project, but I will add, I'll do a quick little stainless steel. It won't be as long as this, or maybe I'll do it before the stream and then show you guys the results, give you guys the settings. Okay, we're gonna be running this one more time. One more time, this is the last time we're running it, and then we're done. I'm gonna wipe it away and hopefully the results stick. Yeah, okay. Stainless steel, guys. I'm gonna laser some stainless steel. I'm probably not gonna do it on stream because I don't want to take away from next week's project. I'm gonna do some stainless steel on my own time, and then I'll come back, I'll show you guys the results, and I'll give you the settings if it worked. I'll give you guys the settings so you guys can also have some fun with that. All right, we got a couple more minutes, guys. We are going to be ending the stream in about 10 minutes. So if you guys have any comments, questions, anything you want to say. Dana, you have a great night. Thank you so much. Thanks for joining us. We appreciate everything you do. Couple more minutes for this to finish. I'm gonna go grab a wet shop towel so that we can check it out. We can wipe away the laser ink spray and we can see what we're left with. Because it looks great. Every time a project finishes, it looks amazing. And then the wipe is the true test. So hopefully we get something good out of this. Guys, if you enjoy these streams, if you enjoy just hanging out, watching the laser go, please like the stream. Give it a thumbs up. We appreciate you. CNC Labs appreciates you. I appreciate you. Everybody on the team appreciates you. Guys, again, if you're having any issues with your laser, just send in a ticket. Any ticket with the word laser comes directly to me. We'll book some time. I've been a little bit backed up, guys, but I'll be having a few customer calls tomorrow, some technical calls tomorrow, so we're going to clear out the schedule so that we can get you guys up and running if you have any issues or if you have any questions. I know, Derek, I'm going to hear from you about the wire situation and the and maybe we can talk about the rotary, and hopefully I can help you get set up a little bit. I will definitely try my best. So we are almost done. Our time is coming to an end. Thank you, Jack. I appreciate you. Again, happy anniversary. And yeah, I like hanging out with you guys too. It's a fun time. I feel like I always learn something. I always make a stupid mistake. I always learn something. I always laugh, and I always tell bad jokes. Charles, congratulations. That's very exciting. Hopefully you enjoy it. Check out our resources. Check out all the videos that we have for you. Get up to snuff. Get your stuff ready to go. If you have any issues, send in a ticket via our website, but not before you check out our amazing resources, because we work so hard on the resources. We work so hard on the videos to try to get you where you need to be without actually talking to any of us. But if you can't get there, or if you have issues, or you're missing something, just give us a call, send us a ticket, and we'll help you any way we can. Welcome to the CNC Labs family, and hopefully you make some really cool stuff and you share them with us and the whole community. We are almost done. I'm gonna go grab another shop towel so that we can wipe away our laser ink. All right. This is it. Thank you, Mick. Guys, if you guys are OG long mill users, you might have gotten sold a long mill from me on the phone, so. So, you know, I was a great long mill salesman at the trade shows. If you ever saw me at a trade show, or if you ever spoke with me over the phone, you may have gotten sold a long mill directly from me. So I do appreciate that, Mick. All right, let's see. You know what? That's just not good. It's not good stuff. With all the amount of runs that we did, I had a feeling that we might get something to stick. But that is barely readable. That is barely readable. You can still see it, but it's not it. This is not what you want to be spending $100 a bottle on. So I will try stainless steel on my own time. I don't want to take up any more of your time playing with this laser spray. Let's get back to what matters. Let's get back to rotary. Let's get back to using the webcam or the camera feature in Lightburn. Let's get back to maybe doing a router job and then overlaying a laser job on it. Those are the projects that are exciting me for the future. So, you know, I'll do a stainless steel test on my own time. So I could just show you guys the results, and if it worked, it worked. I'll share the settings with you, and if it didn't, then we'll just never speak about this. This was just a 6-week long fever dream, 3-stream long fever dream, and we will never speak about this ever again. So, everybody, this is my famous outro and intro. Thank you for joining me tonight. Doesn't matter where or when you are, whether it's the morning, afternoon, evening, or night, I appreciate you nonetheless. Give the stream a thumbs up. We appreciate it. Scott, Lightburn has a feature where you can kind of take an image of something and then actually turn that something into something you can engrave. They also have a feature where you can line things up and start jobs using an overhead camera as well. So in 2 weeks, we're going to go back to the rotary. I'll let you know my results with the stainless steel. Jack, happy anniversary. Scott, thank you so much. Doug, thank you so much. Mick, you're the best. Derek, I'll be waiting on your ticket. We'll chat later soon. Nicholas, thanks for joining. Dana's already left, but thanks to Dana. He's the best. Charles, you are awesome. Welcome to the CNC Labs family. If you joined, if you chat, if you just watched, we appreciate you. I hope you have a wonderful rest of your day. I hope you have a wonderful week, weekend, the whole gambit. I'll see you guys next stream, and hopefully you have some fun with your long mill or your laser or a combination of both. And worst case, hopefully just keep making stuff, keep doing stuff, and have some fun. So I appreciate you guys. I'll catch you guys on the next one. Oh, let me check the last ones. Yeah, good night.